Welcome to Carlton's Math Corner. Today we're going to continue our study on point-slope form. At this time, please make sure that you have your math journal, vocab packet, as well as something to write with. Today, our target is I can convert point-slope form to standard form. First of all, let's talk about what is standard form. Well, standard form, it looks like this. We have a number in front of x, so a coefficient in front of x, and plus, and remember x stands for like x coordinate on a line, plus another number or another coefficient in front of y, and y stands for a y coordinate on a line, equals another number that stands alone. And so when we talk about slope-intercept form, this is what it looks like. And A is a positive coefficient. So it's never a negative, it's always positive. So keep that in mind when we talk about changing a point-slope form into a standard form. A always has to be positive, okay? So look at the steps that were done for the first problem, and then can you tell me, like, what happened in step number 1? Well, I noticed that, okay, in black, this is point-slope form. Remember point-slope form we learned about in the last video. It's y minus y sub 1, and y sub 1 just means a y coordinate off of a point, from a line, equals 2 represents slope, so that's our m, and then parentheses x minus, and then x sub 1 is another x coordinate on the line. So it looks like we started off with this in black, and in order to get step number 1, I noticed that the y minus 10 remained the same. So the left side stayed the same. But look at the right side. In order for us to get 2x minus 16, I know that I would have to do the distributive property in order to get these terms. If I do 2 times x and introduce that to the x, that I get 2x, and then 2 times 8 and I get 16. So 2x minus 16 is in simplest form on that side. How about step number 2? What do you notice in blue? What's going on? Yes, it kind of looks like the 2 is being moved over, because if I take this 2x and I subtract 2x, that makes it disappear. It changes it to 0. And then it moves it over to the other side. Whatever I do on the right side of the equation, I have to do on the left side. I need to keep my sides balanced. And so what I'm left with is negative 2x, because there's nothing here to subtract it from. So I have negative 2x that's left. And then the y minus 10 stays the same. So negative 2x plus y minus 10. And it's plus because this y, there is no negative in front of it. So it's got to be a positive. And then equals, and the negative 16 over here is the only thing that's left. And so negative 16 remain the same. How about step number 3? What do you notice? Exactly. The negative 10 is being moved to the right side. And in order to do that, I had to do the inverse operation. So instead of minus 10, well, the opposite is adding 10. So I'm going to add 10, and negative 16 plus 10 is negative 6. How about step number 4? What do you notice? Well, remember when I said that A, or the first number, the first coefficient, has to be positive. Do you notice that this is a negative 2 that's in that space? Because right now I do have an A and an X, and I also have a B. Even though you can't see it, what number is here in front of Y? Exactly, a 1. And so I do have a B and then a Y equals a C. So I do have it in slope and or standard form. However, it's not truly in standard form unless the A is positive. And in order to make it positive, the only way I could do that is by dividing by a negative. And the only number that I can divide by that won't change that 2, that will only change the negative, is a 1. So if I divide by -1, I get a positive 2. Now, if I divide A by -1, then that means I have to divide everything by -1. And so here's what I get as an answer, because this -2 will change to a +2. This positive y will change to a negative y or minus y. And this -6 will change to a +6. And so here is my answer in standard form. Okay, so let's look at our steps. Okay, so here are our steps. The first thing we did was we used the distributive property to simplify. That's step number 1. Second step, we moved the x term to the left side. And in order to do that, we had to do the inverse property. Step number 3, we got rid of the lonely term. And I call this the lonely term because it doesn't have an x or a y next to it. And so we move that one to the right side. And again, inverse property, always using the inverse property if we want to move from one side to the other side. And then step number 4, this is only if the coefficient next to the x is not positive, then we need to divide by a -1. So we have to make sure that this is positive. If it's not positive, then you got to divide by -1. And we have to divide all terms by a -1. All of them. Okay? So make sure that that is what you're doing to get it into standard form. Now let's look at this problem. What do you notice that's different? Well, the first thing that I notice is right away this has a fraction in it for the slope. And I mean, that's okay. Slope is rise over run, so that's okay to have a fraction. But look what happens that changes things. First of all, I notice that I am multiplying everything by 3. And 3 happens to be my denominator. Okay? Then notice what happens when I start multiplying everything by 3. Okay? Here's what happens. On the left side, I'm taking 3 times y and 3 times 1. And this is one way to show it. This is kind of showing that we're using the distributor property when we take that 3 and multiply it through. So we get 3y minus 3. But look what happens on the right side. If I multiply this by 3, the only thing that happens is the 3 just disappeared. I mean, look at that. That's what I notice, is that the denominator just disappeared. Now think about that. If I divide by 3, so let's say I take 12 and I divide by 3, then I get 4. But if I multiply by 3, like go the inverse operation, then don't I get back to 12? Yes. So dividing by 3 and multiplying by 3, what happens is it looks like they're just canceling each other out. They just disappear. And so what's left is the -2 times the x minus 5. And that's why that's all we see here is -2 times x minus 5. And so we can use the distributive property to simplify that, and we get negative 2x plus 10. Now notice the other, the last few steps are all the same. We're moving the x term to the left side. So that's why it says plus 2x. We want to do the opposite. And then same thing here, we're getting rid of that lonely term and moving it over to the right side. And so we're adding 3 because that's the inverse. And so now what we have left is positive 2x plus positive 3y equals 10 plus 3 is 13. And we make sure that this is positive. It is, so this is actually in standard form already. So the way basically the only step that changed is step number 1. And what I call step number 1 is I call it a fraction bust. I'm trying to get rid of the fraction. I'm trying to get rid of the denominator. And so in order to do that, we multiply by the denominator. And so I'm going to add that to that is we're going to multiply by the denominator. That's how we fraction bust and get rid of that fraction and make everything integers. Step number 2, we got rid of parentheses, so we use the distributive property. Okay, and then step 3, move the terms to the correct side, and we use the inverse operation. And then step 4, I want to add to this, check to make sure the A term is positive. And if it's not, we need to divide by a negative 1. Okay? What I want you to do is try these 2 problems for tomorrow. And I appreciate, you listening in today. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.